Welcome to August 17th LeetCode Challenge. Count good nodes in binary tree. Given a binary tree root, a node x is in the tree is named good if the path from the root node x where there are no nodes greater than the value x. Return the number of good nodes in the binary tree. So given example 1, we have this root binary tree here. We see how the number in the blue is greater than the number in the white, so the parent node has to be greater than the child node in order for it to be considered a good node. So 3 is greater than 1, and we go down to here, 4 is greater than 1, and the rest where blue be the child node would be greater than the parent value. So that's pretty much how we're going to use to find it, and we return the number of good nodes. So it's 1, 2, 3, 4. Example 2 is the similar deal. CF 3 is equal to the value of the parent node is equal to the value of the child node, then it's still a good node. Alright, the root node itself is considered good. So, hint, use the depth first search to traverse the tree and constantly keep track of the current path maximum. So that's what we're going to do for this algorithm. So we're going to use a depth first search algorithm. So in order to do that, let's define a couple of variables. So I'm going to store everything using a stack, so call it stack. I'm going to store the, basically I'm going to store the root node and the entire root tree node given, and I'm going to store the root value in that. Then I'm going to be able to pop stuff off and append stuff to the stack. I'm going to keep track of the output count and assign it to be 0. So next we enter our depth first search algorithm. So while a stack exists, what we're going to do is we're going to update the node to be and the value to be stack.pop from the right side. So the first if statement is going to be if the count is equal to 0 or the node value itself is greater than or equal to the value popped from the stack. Value popped from the stack. Then we're gonna increment count by 1 because it makes it a good node, and we're gonna update our value with node.val. Alright, that's the first step. Next step is if the right node exists, so right node.right, we are going to append that to the stack. So append node dot. Let's go with left first. Left then right. Left node dot left, and append the value. Likewise, if the right node exists, node dot right exists, we're gonna append that to the stack as well, and therefore completing our depth first search type algorithm. Node dot right, append the value, and then what we want to do is return the count at the end of all this. Return count. Let's run this and see if this works. 4 submit. Alright, accepted. So time complexity, it would be big O of n, where n is the number of nodes in the tree and the root, because we do a while loop here to the stack, and at most it's going to store every node inside the stack. Space complexity would be the height, big O of the height of the tree. So every time we do we traverse through here, we have to if we have a node, left node, or a right node that exists, then we have to go one layer down, therefore increasing our stack for our space complexity. Alright, that's it. Have a great day, guys.